Hello, we are here for one more lesson of this T-FLEX analysis training course, and the topic for today will be the purpose and role of meshes. So I've opened one model that we have from the standard installation of T-FLEX analysis, and I'll try to speak a little about this topic. Which is the purpose of the meshes and how they influence the study that we want to do on the elements. So to start, to mention that the main purpose of a finite element mesh is to approximate the geometry that you have from your CAD file to a mathematical model that, as accurate as possible, represents this CAD model. In fact, what we do is to create shapes, small shapes, triangles or other forms that will not replace, but it will cover all the element, and these tiny triangles or tetrahedrons or whatever will be studied element by element, and these are the shapes that the program will study. This has a definitive role and importance in this process. In T-FLEX, we use an automatic generator of these meshes, and we can control some parameters of this process because the user needs to assure that we obtain the desired quality, and this has to be done by a visual check. Okay. There are some recommendations, but they do not replace the experience of the user and the visual check of what is going on in your model, because every case is a case. Along the course, we will see all the parameters that influence this mesh creation, but there are a couple of basic notes that we can pass. So let us say two major topics about this creation method. Firstly, the quality of the solution depends on the shape of the finite elements, and best results of this mesh are achieved if the elements, being tetrahedrons or triangles, it doesn't matter, form a meshed model as close as possible to the CAD model. This is important for any type of model, for sure. And this has to do especially with size. Let's do some examples so that you can see what we are talking about. I will open this study. I have a mesh. I'm not sure if it is created or not. I will create, and I will look only today for two parameters. This one, I will create a bigger one, the mesh size. And we have another parameter, especially for curvature, that influences the quality also of the model, of the mesh. So I will say also 1 millimeter. And okay, let's create the mesh. And as you can see, now I have my mesh model, and you see that because I've given a very high value, I have my mesh deformed, and because the idea is to have these triangles, this shape, respecting as much as possible and approximate the CAD model, I will obtain for sure results on this mesh, but they should be not very accurate because they do not represent very well my model. Let us try to go there and change some parameters. I will decrease this. I will say now, instead of 1, I will say, for example, 0.2. So I'm refining my model, and now it is a little different. These round areas are more precise, even that I think they are still very rough. And you see that this, compared with the first mesh, should give us a more accurate result. But even so, I think it's not so good, or at least it's not represent still the accuracy that the user should expect from a study. Another important parameter, and this is a visual check. The size of your mesh should be, as far as possible, these shapes should be more or less regular. So it's not very good to have very big elements in one area and very small elements in another area. It depends also of the area of your element. This is a planar area, so it's not needed to have smaller things to define the shape. And here we have smaller shapes because it's round and it needs a better refinement. But as far as possible, we need to decrease this size. This is the shape of the finite elements. It's what we can call the degree of discretization of the original model. What is, in fact, it's or more easy, it's the density of the mesh. We can control this density, as you've seen. We can influence by the parameters the number of elements and the final shape of the mesh model. But it is important to notice that a finer division gives you better results in terms of accuracy, but it will require higher order of the equations that are involved on the calculation, and it will affect for sure the speed calculations, and it will demand more power from your machine. If you invert this, you'll get all the opposite. Okay, let's try to change a couple of parameters more. So I've changed the curvature. I will reduce now my mesh size. I will put this in 50 microns. Let's create another mesh. So you see now the mesh is much better, and you see that my model now it's very good. It's very regular. The shapes are more or less the same size, so I'm quite happy with this result. Even that in this detail here, because it is a very small detail, I'm not still very happy with this part. So I should increase a little the definition, and I can do this on the curvature, saying that the mesh size on the other places it is good, but in this curvature area I would say, for example, 0.2, and okay, let us create a mesh and see. Okay, you see now in this area it's increased a little the number of elements and the definition. I can still go. Let us create, or even let's exaggerate a little. It will create a little bigger, not so much difference, okay, but it will increase a little the curvature and what is needed. Let us do the opposite. I will, on the mesh size, this is the global mesh size, I will increase this to 20 microns, and it will take a little more time because now you'll see a much greater definition of the mesh. You see now much better with a lot of elements. Now it will take much more time because, as I mentioned in the beginning of this lesson, for each element the program will create a mathematical study of the loads and of all the conditions that are present. We should try to have as regular shapes as possible. There are some areas with some problems, even that in this particular model it should be no big issue because it's more or less it's not a very complex shape, but at least it is something that we should be aware, and the user, before going to the calculation itself, should make a visual inspection of the model and try to work around some areas that also with experience that it may found that lead to not so accurate results. Okay, so this is a general explanation about the meshes and how they can influence what we are doing here. Along the way in these videos we will talk about the parameters, and we will understand better all the parameters, what we can do with them and what we can expect in terms of the influence on the final result. So for now, I hope that this brief notion of the meshes and these examples were clear enough to make you aware of what is this topic of meshes and how to work with them. Any explanations, any help that you may need about this topic, you can contact us through the usual channels.